Hi there, Bon Crowder with Math4.com. Math is not a four-letter word. Here talking about domains in functions, and in this case, this doesn't really have to be a function. This is just a formula, so and that's okay because the domain still holds here. So looking at y equals square root of x, we're considering only the issues for even roots in this case. So what's the problem? What's the possible issue here? Well, you can't take a square root of a negative number. So for instance, if I said x is -4, we would have a problem trying to find an answer to this because there's no two numbers that multiply, or there's no single number that multiplies with itself to give -4. So negatives are out. What about 0? If x is 0, well, then y is the square root of 0. Since 0 is multiplied with itself gives you 0, that's an okay answer. So negatives are out, 0 is in, and of course positives are in. So our domain would be all real numbers that are non-negative. So why do we say non-negative instead of positive? Because 0 is neither positive nor negative. So if I said positive, I'd be leaving this little guy out, and he's kind of important. So, or at least we don't want to make him feel bad. So the domain is all the reals that are non-negative. If you drew it on a number line, here's 0, you would say including 0, so you dot him and do it like this. Or if you like the square thing notation, here's 0. And you could do also the set of all x such that x is greater than or equal to 0. And there's the domain for y equals square root of x, considering the potential problems that you could have in the square root. So I'm going to fade into another screen and do a little bit more complex one. Be right back. Okay, here we are, back again. So I have the function y equals square root of x plus 2. Well, again, we have to consider what in the denominator is, what's going to happen in the denominator to make it negative, because that's the problem. So anything that makes the denominator negative is out. It's not in the domain, so we just reverse what we say, and we say the domain is everything but this stuff. So remember that when you teach this, this is not solving the problem. Students have a tendency to think, oh, this is how you solve the problem. Well, not really. When we talk about solving the problem, we talk about actually solving this. We're actually analyzing the problem. So, analyzing the problem, we take out the piece under the radical sign, and we want to keep anything that's greater than or equal to 0. Likewise, you can figure out what you want to throw away, like I was just talking about, and that's typically more for negatives in the denominator. So we're going to keep everything that's non-negative, that's positive or 0. So now we have to solve for this inequality. And remember all the inequality rules. Luckily, we don't have to do any flipping of the gator mouth in this case, but do all the rules if that applies. So our domain is all reals greater than or equal to -2. Likewise, we can draw this on a number line. There's -2. We keep -2. Or you can do it with the circle. -2 and then make a big black dot. And so on. Or we can do all x such that x is greater than or equal to -2. And remember, the subtle difference here is when you're dealing with domains with problems in the denominator, then you're looking for what makes it to be 0, and then you're saying whatever's not that is the domain. for radicals, for positive roots, you can just straight away say whatever this is, that's what we keep. So that's a way to find the domain specifically for positive roots. I'm Bon Crowder with Math4.com, reminding you that math is not a four-letter word.